Hello, and thank you for watching this webinar. My name is Remco Dijkman, and I am Research Director High-Tech Supply Chain at the European Supply Chain Forum. And today I want to talk to you about demand forecasting, and specifically demand forecasting with artificial intelligence. Now, you're probably watching this webinar because you're already interested in demand forecasting, but want to know what artificial intelligence brings to that mix. But before we go there, we need to agree on some basic mathematical functions that allow you to fully appreciate what artificial intelligence can bring to demand forecasting. Now, throughout this webinar, I will use the example time series that you see over here. This is a rather famous time series. It shows the demand of airplane passengers in the United States in a period between around 1950 and 1960. And what you see is that, as you would expect, there's an upward trend in the demand for airplane seats. And also there is what we call seasonality. So you can also see some clear yearly patterns. Now, basically demand forecasting is a form of regression where we have data points, such as the ones that you see on this slide over here. Right, we know for January 1950, February 1950, what the demand was for airplane seats. And we try to fit a function to those data points. And then once we have learned that function, we can use it to predict the demand at a later point in time, for example, January 1962, which of course we also already know, but that is the example. So in that respect, it is very similar to classical regression, where in linear regression, for example, we learn a function such as the one that you see on this slide, y equals ax plus b, and we try to learn based on the data points that we have. We try to learn the value for a and the value for b, and once we have learned those values, we know the complete function, the line that you see on this slide, and we can then use that line to predict the value at another point in time, for example, at x equals 60. It is just that in demand forecasting, we use a bit of a different function. And this is one of the classical functions that we can use. It's an autoregressive function, and it's autoregressive because it depends on itself. It regresses on itself. But the idea is the same. We try to learn this function. We try to learn based on the values that we have on this slide, the data points. We learn the value for a, we learn the value for b, and then we have a complete function, and we can predict the value at a later point in time, t, based on the value at an earlier point in time, t minus 1. Now this just shows one lag, as we call it. So we make the demand just depend on the previous demand, the demand at the time t minus 1. But we can, of course, make it more complex and make it depend on multiple steps or multiple lags in time back. So that is basically what demand forecasting with classical methods is about. It is about learning a function, such as an autoregressive function or one of the more complicated functions that you see on this slide, learning such a function based on data points that you have, and then using that function to predict the demand at a later point in time. And actually, demand forecasting with artificial intelligence is not so dissimilar from that. Also, in demand forecasting with artificial intelligence, we try to learn a function based on data that we have. It is just that the function looks a little bit more complex than the classical function that you see over here on this slide. It would look, for example, more like this. So this is a function from the world of artificial intelligence. Specifically, this function represents a recurrent neural network. And a recurrent neural network is specifically targeted at being able to predict time series. But as you can see, the function that you have on this slide, it's much more complicated than the function that we used when we did autoregression. So it's more complicated, and also it has more parameters to learn. So where the original function, the autoregressive function, we just have to learn 2 parameters, a1 and a2. In the artificial intelligence function, in the recurrent neural network, we actually have to learn 5 parameters. We have to learn the b, the w, the u, the c, and the v. So we have to learn more parameters, which also makes the function more complex. And in actuality, it's even more complex than what you see on this slide, because the function that you see on this slide is for learning with just one leg back. So just look at the yt minus 1. So just the demand from, let's say, the previous day. But we said that we're going to look 2 steps back. So y at t minus 1 and y at t minus 2. So then this function is repeated twice. And we can even make it more complex than that, because very often in artificial intelligence, we also start stacking the functions. And this is also what is referred to as a neural network architecture, where we combine one function, such as a recurrent neural network, the one that you saw on the previous slide, with another function, for example, a dense layer of a neural network. So we use then that combination of functions to make the demand forecast. So that is, mathematically speaking, what the difference is between classical demand forecasting and demand forecasting with artificial intelligence. So they're very similar in the sense that both try to learn a function that they then subsequently use to predict the demand at a later point in time. Only in classical demand forecasting, that function is a classical function, such as an autoregressive function or an ARIMA function. In demand forecasting with artificial intelligence, the function is typically a neural network, such as a recurrent neural network or a long short-term memory neural network. So that is, mathematically speaking, what the difference is. But of course, the big question is, what does that mean in practice? Well, because the functions that we learn with artificial intelligence are much more complex, they can also learn much more complex demand patterns. And for that reason, and because our demand, of course, in reality is rather complex, for that reason they can also make more accurate predictions under more complex demand situations. So that sounds ideal, but it comes at a cost, because these functions are more complex, they have more parameters to learn, and they also need more data to learn those parameters. So it needs more data, and of course you have to have that data available. Also, because these functions are more complex, they're less easy to understand, and for that reason the demand forecasts that you make with the functions are not always easy to explain or to understand for your planners. And for that reason, your planners may be inclined to not trust the demand forecast that the functions make, because to them they're a black box, they don't understand why this demand forecast is made. So it also has drawbacks. Now these benefits and drawbacks, they're best explained by the example that I have on the next slide. And what I did on this slide is I actually made 2 forecasts, one based on classical methods and one based on artificial intelligence. And specifically for the classical methods, I used a autoregressive function with looking 2 steps back. And for the demand forecasting with artificial intelligence, I used a recurrent neural network, also looking 2 steps back, and combined that with a dense layer. Now what you can also see on this slide is that to the original time series, I added a forecast for the last 2 years. Of course, we know the forecast for the last 2 years, but this allows us to see what the difference is between the forecast and the actual values that were realized. And then you see that in the demand forecast with artificial intelligence, this forecast is pretty much a perfect overlay with the original time series, meaning that artificial intelligence creates almost a perfect forecast. You can see that the forecast with classical demand forecasting techniques is also pretty good, but there is a little bit of a difference. So it is less good than the one with artificial intelligence. And that's also what I said as one of the major points of demand forecasting with artificial intelligence. It typically creates better predictions. What you here then also see is the functions that it has learned. And there you see that indeed the function that the neural network learned is much more complex than the function that the autoregressive method learned. So the function that the neural network learned, I didn't even put the full function on this slide, I just put the parameters on this slide, and it shows that it has learned 13 different parameters. where the autoregressive function just had to learn the A1 and the A2. And you can see that the A1 was 1.3 and the A2 was minus 0.3. So it's a much simpler function, meaning first, we needed less data to learn this function. Now, in this example, that wasn't a problem. The AI was quite capable of learning its function, because you can see that it makes very good predictions, almost perfect predictions. But of course, in realistic settings, that may be a problem, that you need more data to learn. You can also see, because the autoregressive function is simpler, that it's easier to understand what's going on here. So it shows that the demand actually depends more on the demand one step back than the demand two steps back, because it depends with a factor 1.3 on the demand one step back and with a factor 0.3 on the demand two steps back. So that's more easy to understand. It also shows that compared to the demand one step back, it actually pulls up the demand, and the demand two steps back pulls down the predicted demand. So that provides your planners with important information, so planners understand what's going on here, and they will trust, or at least trust more, the results than they would with the artificial intelligence method. Now, this is of course an example that is highly stylized. In reality, probably your demand series, they don't look as well behaved as this one. They would look a little bit more like that. And then of course the question is, do these conclusions, so that demand forecasting with AI has an added benefit, it predicts better than classical demand forecasting, do those conclusions still hold? Now on this slide there is some anecdotal evidence. A couple of our master students, so there are 5 master students that are shown on this slide, worked at European Supply Chain Forum companies to make demand forecasts with AI, and then also compare them to the demand forecasts that were made with classical demand forecasting methods. And what you see in the results on this slide is that, yes, it turns out that in many cases, indeed, the demand forecasts with AI were better. There's a bit of a disclaimer here. In some cases, it may appear that the forecasts were much better, so up to 20 or even 30%. But I have to add that this is over demands that were originally actually not very good. I don't blame the companies for this. Demand forecasting is just very hard. If your demand fluctuates a lot, it's just very hard to create a good forecast. But then if your original forecast was 50% off and now it's 40% off, yes, you are doing 20% better overall, but you still don't have a very good forecast. So, but overall, the conclusion can be that yes, AI does predict better than classical method based on what these students did. And that also brings us to the general conclusion: does AI help to predict demand and predict demand better? The conclusion is yes, but it is no silver bullet, because AI does require more data to learn the functions that in the end predict the demand, and you have to have that data available. And also the models that AI learn are much more complicated, so they're less explainable. Your planners will be less able to understand what is really going on, and for that reason may trust those methods less. But when done right, AI does help to predict demand in more complex demand situations and does help to predict it better.